Ah, welcome back. I hope you enjoyed your weekend, and I hope you enjoyed the work with the calories, and you have a new appreciation for how ridiculous it is to have two different sets of measurements of units for such an important quantity on foods throughout the world. Um, I hope you were able to look at least one food label over the weekend and just be like, huh, that is all there, isn't it? And then kept it moving. What we are going to do today is we are going to start getting into the big concepts of energy, the most important concepts of science that I have been mentioning for the last week. We did all of the the pre stuff. So now what we're going to do is we're going to get into some of the nitty gritty today, and some of the math, and some of the good stuff. So, sorry, this is my dog sleeping. These terms, potential and kinetic energy, many of you throughout the year have told me that you remembered these terms from middle school science, like, oh, potential energy, I remember that, one goes up, one goes down, all that good stuff. Yes, this is what we're going to get into. If you don't remember this at all, that's fine, but if you do, you will have a leg up for today. I think I gave a list of like 6 different types of energy. What we're going to do is we're going to get to good detail on 2 of those types, starting with potential energy. Now, this is by no means the only type of energy. These are not the only 2 types of energy, but these are the energies that we're going to focus on right now. Potential energy is the energy of location. Now, this one's a little tricky to understand because how can an object's location or position determine its energy? So I propose to you to do this. If you pick up your phone and you just hold it ever so slightly above your desk and you drop it, it barely moves and no real damage happens to it. But if you hold your phone high up into the air and then drop it, there is a good chance that you could get some damage to the phone. The only difference between those 2 situations, gravity pulled it down both times, but the only difference between those 2 situations was the height, how high above the ground it was. Lifting it into the air gave it energy. So if you think about it, if I lift like a book into the air, right, I'm doing work to the book. I've given it energy. If I let go, the work that I did to it is now its energy. So it's going to release the energy and fall back down. And then if I let go of the heavy book over my head and it falls and hits my head, then that book would then do work to my head by moving my head. And all the energy is just transferred between the objects. So the higher up off the ground an object is, the more potential it has to do work. That's why it's called potential energy. It doesn't mean it's the energy of falling, but it's the energy of the potential to fall. So PE equals mgh. Potential energy equals mass times gravity times height. This is an important equation. We will see this a lot. It says, what is the potential energy of a 3 kilogram rock sitting 4 meters high? Bam. A little sophisticated today. Did that all out. Oh, wait, Pizzuto, question. Why is it positive? Isn't gravity negative? Yes, you're right. Gravity is negative. But energy is not a vector. Energy doesn't really have a direction. So because energy doesn't have a direction, we don't need positives or negatives with energy. So what we're going to do is, even though gravity is technically negative, we're going to treat it as if it's a positive. Because we're not saying that it's going right, we're just saying it's going in no direction. So from this here on out, gravity will be positive 9.8. Rather, it would be signless, not positive, not negative, but mathematically you treat it as positive. So 3 times 9.8 times 4, and then energy is measured in joules, because science. So, quick recap. Any object that is above the ground has a potential energy. Objects that have the potential to fall have potential energy. So this rock is still. It's not moving, but it has potential to fall. So we will say that it has potential energy. Kinetic energy, I mean, we have broken the root word of kine down many a time. We know that kinetic means movement, just does. And so kinetic energy is the energy of motion or movement. This is very obvious. If you're going faster, you have more energy. I said energy in the base definition was the ability to move. So if you're moving, you need energy. The faster an object moves, the more energy it has, the more work it can do. This is the equation. Ke equals 1/2 mv squared. Kinetic energy equals 1/2 the mass times the velocity squared. So what is the kinetic energy of a 1,000 kilogram car moving 3 meters per second? Simple. These equations are so basic, I don't think we need to review them that much. So any object that is moving has kinetic energy. And only objects that are at rest or at a stop have no kinetic energy. Okay, so you said, well, we don't need to practice the equations per se, but we need practice at the situations where you can identify when you have kinetic energy. So the horse race, going fast, tons of kinetic energy, but if you are not moving, you have no kinetic energy. I imagine that a lot of you may have very little kinetic energy throughout the course of the day. Okay. Quick recap. So for those of you who have not been diligently taking notes on the slide, here's your last chance to recap the things that you need to know moving forward. Units. All energy is measured in joules. Here are your two equations. PE equals mgh. Ke equals 1/2 mv squared. The mass, m, is going to be measured in kilograms. The height is going to be measured in meters. The velocity is measured in meters per second. And gravity is just going to be 9.8, okay? I mean, I know it's meters per second squared, but let's not even try to confuse it with that. I just want to say, every time you see the G, it's 9.8. Pause it if you can take notes, because I'm going to keep it moving. Oh, that was nice. In class, I couldn't just pause. One thing I want to kind of get clear is that mass is present in both energies. So mass, obviously, is an important factor in each energy. But the difference is, well, that of course gravity affects potential energy, but gravity is constant. Gravity is not going to really change unless you leave planet Earth, which we're not going to really do. So even though gravity is only in PE, gravity is not in KE, gravity is not going to really change. I want to focus on how height and PE are connected and how velocity and KE are connected. So height and PE are connected. As the height changes, the PE changes. So I said if you have greater height, you have greater potential energy. So if this number is bigger, then this number is bigger. Okay, we remember that. But if the height is 0, if you are on the ground, you have no more potential to fall, because you can't fall anywhere. You're all the way on the ground. So we can see the potential energy is 0 joules. Now wait a minute, Bizzuto, hold on 1 second. What if I'm on the ground, but I'm like on the 2nd floor of my house? So I'm on the ground, but so essentially what we mean is like above the actual Earth. So if you're on the 2nd floor of your house, you do actually have potential energy. So I wouldn't say you're on the ground if you're on the 2nd floor of your house. That really doesn't make sense. You're not on the ground. You're on the floor. You're not on the ground, though. Quick little distinction there. So if you ever see words like on ground, what it really means is that your height is 0. And if this is 0, then this is 0. Okay? If you have no height, you have no potential energy. Similarly, velocity and kinetic energy are connected. So we're going to see in the coming weeks how these relationships are a little bit more complicated than this, but let's just think about this for right now. So if you have 0 velocity, if you are at rest, you don't even need to calculate the kinetic energy. You just know that it's 0. So here's where some concepts will help with the math. Surely you could plug in 0 here. You could do 0, 0 squared is 0, 0 times the mass is 0, half of 0 is 0, and you could solve all that. I know you can do that. But again, trying to give you shortcuts to understand conceptually what's going on. Kinetic energy relates to velocity. potential energy relates to height. Okay, let's do some quick little questions. Okay, so it says, what is the height? Okay, so we're looking for height. Height equals question mark of a 50 kg steel beam. 50 kg. All right, 50 kg is the mass that has 7,000 joules of energy. Wait, hold on, Bozzuto. How dare you? How dare you say you have 7,000 joules of energy, but you don't tell me what type of energy? Well, I did that quite intentionally because I want you to tell me what type of energy it has while hanging at rest. Okay, if I know it's at rest, I know that the velocity is 0. And if I know the velocity is 0, I know that the KE is 0. So for right now, because we're only dealing with two types of energy, if the KE is 0, the 7,000 has to be PE. Nice. So it was a curveball, but not really. It's concepts mixed with math, so I like it. So PE equals MGH. So 7,000, wow, equals 50 times 9.8 times H. For simplicity, let me just go ahead and solve that. And let's get like 14.29 or something. I rounded, but if you didn't round, oops, 14.29. If you didn't round, you said 14.28, that's fine. Not a big deal on that. Is the height. Nice. I love decimals. Ah, okay. What is the mass? Okay, so we're looking for a mass. All right. At rest. At rest. KE is 0. So that means if we see energy, it's got to be potential. 4 meters high. 80J. Now, because it's 80J is energy, because I know the kinetic energy is 0, that the 80J has got to be potential. Nice. PE equals MGH. Wow. Yes. Yes, you could always do it like that. The G will always be 9.8. When you plug in, though, and this is 80, and the height is 4, it's going to be really simple. And you should get, like, the mass is 2.04. Yay! Nice. Kilograms. Ah, okay. What is the velocity? Velocity equals question mark. 4 kg. Mass 4 kg. Rolling on the ground. When something is on the ground, its height is 0. And if the height is 0, then the PE is 0. So you see what I'm doing here? I think you could kind of see how I was working. With 18 joules of energy. Now we know that that energy isn't just any energy. For purposes of what we're doing, it's definitely not potential, so it's got to be kinetic. Oh, by the way, please don't call it kinetic energy. It's kinetic energy. So we're going to use KE equals 1/2 mv squared. 18 equals 1/2 4 v squared. I think we know how to do this, but I am going to go through that just in case. So you've got to take half of 4 first. Divide both sides by 2. I'm just flying through this math because I feel like we've been doing this math all year. And hopefully there aren't any questions on it. But again, if there are, I'm here. Follow the steps. Nice. Ah, okay. So what is the mass? Looking for the mass. Geez, I imagine some of you have probably fast forwarded through these simple questions on the ground. They'll miss my insightful commentary then. If it's on the ground, that means the PE is 0. But because it says 15 m/s, I know the velocity is 15 m/s, and this energy has got to be the KE because it's not the PE. Zudo, why did you give me this crazy freaking number? Because I cared. That's why. Plug into the equation. 28125 equals 1/2 m 15 squared. I actually do want to go through the math on this one real quick. I know we've done this before, but it does get tricky. Square the 15 first. So 1/2 m 225. Bring down the 281,250. Then take half of the 225. Even though there's the m between, you can do half of 225. Half of 225 is, of course, 112.5. Equals that number, 281,250. Then divide it by the 112. And then you get the mass is 2,500. Nice. All right. Nice. Okay, so the total energy of an object is simply just the sum of all the energies the object has. So we are talking potential and kinetic added up together. If when we get other types of energy like thermal, we'll just throw thermal onto the equation. We can just keep adding the other types of energies. But for now, let's just say that the total energy is potential plus kinetic. So the total energy is potential plus kinetic. And again, all energy, if it's energy, it's measured in joules. So it says, what is the total energy of a 3 kilogram bird that is flying 4 meters per second while 7 meters high? Real simple. You calculate the PE, you calculate the KE, just add them up. Okay, let's do it. Easy, too easy. All right, so the mass is 3, gravity is 9.8, and the height is 7. KE is 1/2 3 4 squared. This is probably middle school math, and I don't mean to insult anyone's intelligence here. I know you can do this. I'm just trying to get this in here as quickly as I can. So we have a total energy, we just add them up, and you get 229.8 joules is the TE, or we can actually call that the sigma E. We'll get to that later though. The total energy is 229.8 joules. And lastly, this is the only little bit of curveball I might throw you guys. I mean, I'm going to throw you guys a curveball. What is the total energy of an 8 kilogram box at rest sitting on a 2 meter high shelf? Okay, so PE, MGH, KE, 1/2 mv squared. Okay. PE is going to be 8 times 9.8 times 2. And then the KE is going to be 1/2 8. Hold on. Wait. There's no velocity. Of course there is. Of I cannot tell you. If you just saw at rest, you could have just written KE equals 0 from the get-go. That's not the answer, because the answer for total energy is going to be the PE plus the KE, but that would have saved you a little bit of time. And shortcuts make all this a little bit easier. So in this case, when I get the total energy, the potential energy is the total energy, because 156.8 plus 0 is 156.8 joules is the total energy. Nice. Nice. It's two simple equations, doing math, and just recognizing a few patterns with them. Nothing crazy here today. All right. That's it for this Monday. Again, if you need help, please ask. It's starting to get a little more challenging, just a little bit. Maybe not. I don't know, your opinion. And I have office hours daily from 12:30 to 1:30, except it's Friday. I actually get to go into BL and clean out my room because they're going to let teachers in one at a time, one per day, to do that. Crazy. So I will see you guys next time.